Okay, so I'm going to give a quick introduction to show you where we're coming from, some context. So in 2006, I was asked to coordinate the hardware and timing section in the controls group of the DIMS department at CERN, and I quickly noticed it's mainly made of two teams. The hardware designers, they do lots of PCB design, HDL development, and then the software, the low-level software people. So mostly embedded Linux systems, device drivers for the boards we design. And I quickly noticed how different their environments were for developing and how difficult it was compared to their software friends for the hardware people to share their work, to bring in extra help without compromising the long-term future, without any vendor locking situations, to collaborate with industry, with some well-established legal framework, and so on. So we identified a number of challenges, and we overcame one after another. So one was we didn't have a place on the web to collaborate. We created the Open Hardware Repository. Another one is we didn't have a proper legal setting, and there's, of course, companies like to have a clear situation, legally speaking. So in collaboration with our knowledge transfer friends, by the way, I should say, we have the pleasure to have there are 3 colleagues from the CERN KT group, knowledge transfer. So there are lawyers in the room. So whatever I say which is wrong, they will react. And for any hard questions, I will deflect them automatically. So yeah, we did the CERN Open Hardware License, which is mostly for PCB designs, tangible type of stuff. And then we worked out business models with companies so that they could make a living, because companies are an essential ingredient in open source hardware. And then we tackled the last big hurdle we have is the tools, actually, the development tools, the lack of free software tools to do hardware design, and we are contributing to Icarus and to KiCad, which is a PCB design tool. So that's the context. So we tackled the hardware problem, I think, pretty well. But there's still this thing which is kind of straddling in between HDL development. Okay. There, for the licensing, we have been using LGPL in the past. It's not a closed decision. It's not something that we consider a finished debate. But I know many people have argued in the past that LGPL and GPL, which are licenses that were obviously developed for software, do not match the HDL development world very well. And by the way, I should say we come from a copyleft mindset. Okay, so that's also what we try to express in the CERN Open Hardware License. At least our section at CERN is typically copyleft. And CERN has guidelines for open source software, and the recommended license for open source software at CERN is GPL. So, having said all that, what I did for this talk is an exercise of actually reading the license and going through all the definitions, and I found out that it actually can work, in my opinion. So it's going to be an interesting debate afterwards, of course. But what the version 3 of the licenses has done is it has taken all these terms that mean nothing to us, HDL developers, and it has redefined them so that actually you can cast, I think, all the HDL development terms into these things like program, like covered work, and so on, which are defined to mean something else than what your common sense would tell you. Okay, so just a very brief introduction. Of course, non-copyleft means you are allowed to do many things with the source as a licensee, and in particular, you are allowed to modify it and distribute it without having to license under the same license. You can mix and match with proprietary stuff. The main examples are BSD, MIT, Apache, and it works very well for many projects. Copyleft tries to establish a virtuous circle of sharing by ensuring that modifications, if they get published under the same licensing scheme. And there is strong copyleft, where you actually require that all the sources that went into your covered work are distributed under GPL, and weak copyleft, which only requires that if the original sources were LGPL, if you modify those or publish those are published under LGPL. But if you combine it with proprietary or other licenses, there's no requirement that those get published under the same license. So these were written with software in mind, clearly. I do think that GPL version 3 was written with HDL in mind as well. In the very beginning it says it applies to copyright, covered works, or works covered by copyright-like law, like the Semiconductor Mask Act. So there was in their minds of the drafters of version 3 of GPL the fact that semiconductor masks and things like that should be covered by GPL, or they would possibly be covered by GPL if that is the wish of the licensor, of course. Okay, so some very quick words, because I don't think we need for this audience any much detail on this. When you have HDL sources, they can take 3 different paths. They can be run through synthesis and place and route and become a bit stream and then configure an FPGA. They can also be fed again synthesis, place and route, generate silicon chip masks after layout, and be used for the fabrication of a chip in a foundry. And they can also be fed to a simulation engine and result in waveforms and reports. And in this case, this third case, there is absolutely nothing that distinguishes HDL from software, at least from a legal perspective. Okay, going in more detail in the 3 flows. So in the simulation flow, you have a simulator and you feed it a number of sources. Some of them can be free and open source, and some of them can be proprietary. You run the simulation and you get the results. For FPGAs, you have sources at the synthesis level, fed to synthesis, which are again HDL sources, either free and open source or proprietary. And then you have typically these wizards in the Altera tools, the Xilinx tools, that will generate, for example, an instantiation of a very complex component with many options based on some input from the user, which can be under the form of a configuration file. And in this case, the configuration file could be free. The vendor-specific files are typically all rights reserved. They get fed either synthesis or place and route. You can also input net lists from third parties, and then bitstream generation, and off you go with a configuration file. Asic Flow, I am not an expert. I haven't even opened one of these tools ever. So, but from a legal point of view, it's very similar to the FPGA simulation. You have the leftmost box inputs, which can be a mix of free, open source, and proprietary, and then there's a flow, and at every stage of the flow you have non-optional files, which are proprietary. Okay, so now let's go through this exercise. Please bear with me. This is a longish kind of list of terms. So let's go one by one through these terms and see what they mean. First of all, program. It refers to any copyrightable work released under this license, which is the GPL. This is from the GPL 3 text. That means it is not a program that's running anywhere. It's just anything that is copyrightable and you declare as being covered by GPL. Okay? So in the case of simulation, I would say it could be the HDL sources and the test benches. In the case of FPGA design, HDL sources and the configuration bitstream as well. The configuration bitstream is a binary that's like any binary for a microcontroller that will run. So it is covered by copyright. And for ASICs, HDL sources, the masks, because according to this act, Semiconductor Act in the US, they are covered by copyright-like law. And maybe even the chips. This is something that we will see, and we will also trigger a lot of discussion. My colleague David Mazur here will give a little talk after mine to discuss specifically that point. Covered work. So once you have the program, you can modify it, and modifying it means what we usually mean by modifying. And then a covered work is just either the unmodified program or a modified program, work based on that program. Okay. So again, in simulation, HDL sources of the designs and the test benches, in the FPGA flow, the HDL sources and the bitstream, and the Asic Flow, HDL sources, masks, and maybe the chips, exactly as for program. Conveying. Conveying means shipping stuff in a way that will allow the users, licensees, to receive copies of the covered work. So for example, in the case of simulation, putting HDL on the web, that's conveying. In the case of FPGA, putting HDL or bit streams on the web, that's conveying. Or shipping FPGAs with their bit streams in the same PCB, either in the same chip or in an external flash, that is also conveying. In the ASIC world, HDL or mask files on the web, and maybe also shipping chips. Source code, the preferred form for making modifications to a piece of work. So in the case of simulation, so that means basically no netlists, for example. The source code is, in the case of simulation, HDL files, config files, scripts. Same for FPGA, and same for ASIC, plus I would say the CAD files when we start doing layout. That's also the preferred form of the work to make modifications to it. Object code. Any non-source form of our work. Okay, so again, we are departing from the common sense definition of object code. It is not necessarily a binary. It is any form which is covered by copyright and which is not the source form. So models in binary form for simulation, netlist, bitstream, as a file, or in the FPGA, in the case of the FPGA flow, and in the case of ASICs, netlists, mask files, chips, maybe. System libraries, this is an important one as well. So typically in the software world, this would be actually system libraries, so you don't need to ship those in the case of a GPL covered work. If it needs some system libraries to run, you are not required to distribute them when you publish your work, because you assume that the users have access to them and they can run your stuff easily. Here, there's a little complication. So major component, as it's defined here, would be something like a simulator, for example here, an interpreter, or also designing tools or the Altera tools. That would be a major component. So anything which is shipped with a major component and whose only purpose is to allow your stuff to run with that major component, that's a system library. The problem I see, for example, with the Unisim libraries of Xilinx, they are shipped with the Xilinx tools, and you end up using them with a simulator, which is not the Xilinx tool. So by this definition, the major component would be, because it is shipped with it, it would be the Xilinx tools, but it says the only purpose it serves is to make it work with that major component. No, it works with another component, which is a simulator. So there could be a problem there. That's why I say these models of technology primitives could be an issue. Okay, I put a question mark there. So, for FPGAs, yeah, libraries of primitives, ASIC silicon cell libraries. Corresponding source. So basically, all the source you need to generate a useful piece of work. So in the case of simulation, ACL for the design and for the test benches, also scripts. FPGA will be the ACL sources, config files and scripts. And the same for digital ASICs. Now we go into LGPL terminology. So that was all GPL definitions. In the LGPL, again, things are very non-intuitive, but still, there is a definition, so you go by the definition. Library, covered work governed by this license. That means if you publish files and you put an LGPL header on them, that's a library. That's the set of those files is a library. Other than an application or a combined work, we will see what it is. But basically, application is the rest of the things, possibly proprietary, but then you're going to combine with the library to make a combined work. So, HDL sources mostly, config files and scripts in 3 flows. Combined work is what you get when you combine the library with an application, which is the potentially proprietary part. And the combined work for the 3 flows is, in the case of simulation, complete input to the simulator. So here yeah, it's a complete input, complete set of files. FPGA development would be the complete input to synthesis, and also the FPGA bit stream. And in the ASIC, it could be the complete input to synthesis, the mask files, and maybe the chips as well. Minimal corresponding source. Let's see the last one. It's the sources of the LGPL subset of the things you feed into synthesis or into simulation in case of the simulation flow. Okay, so some open questions. First of all, if you're in a copyleft mindset, I think LGPL and GPL are usable. They are licenses which are, and the advantage they have is that they're very well established, backed by an organization which is solid. They have been used in the software world very often. There seems to be a relatively simple mapping of all the terms to what we are used to do in the HDL development world. So if you are, and this is a big if, of course, in a copyleft mindset, then the question is LGPL or GPL, and the answer technically is very simple. You look at these diagrams here, for example this one, and you ask yourself if you want to allow a situation in which this leftmost box receives only blue stuff, or if you want to allow some proprietary blocks to be fed into the synthesis box. If the answer is yes, if the answer is that you want to allow that situation, then you go for LGPL. If not, you go for GPL. So it's a very simple technical decision. Of course, non-technically, things become more complicated. So it depends on what your goal is. There's always exactly the same debate as in software. What kind of adoption can you expect if you license under GPL? Maybe some people are not going to want to use your core because they have a lot of proprietary stuff they want to mix and match with it, and they are not ready to release it. And then that could result in you taking the decision of using LGPL instead. But if everybody does that, then we never reach the critical mass needed to have a nice GPL environment. Right? You probably all know the success stories in the software world. One of the big components of that success, of course, it was copyleft, but also the availability of a large body of work which was high quality and which was licensed under GPL. So the critical mass was there to begin with. So it's a tough debate. GPL or LGPL. Many people use LGPL half-heartedly, so to speak. Okay, another open question has to do with LGPL 3 paragraph 4D, and the question is whether this requirement that I'm going to explain makes LGPL 3 effectively equivalent to GPL 3. The requirement of LGPL 3 is that whoever receives that work, body of work, should be able to upgrade the LGPL components to a newer version of the LGPL components. So the licensee who has received these and redistributed it has to abide by the terms of the LGPL, and that requires that he or she provides to downstream licensees enough material to be able to recombine the proprietary parts and the new version of the LGPL parts so as to create a new work. Okay. So if there's a proprietary part to the design, I don't know, it could be that they choose to distribute the netlist only if they don't want to disclose the source code. But how efficient is that? Is that really equivalent in terms of the possibilities of optimization? Are we not missing opportunities by not having the complete source, missing optimization opportunities? So it might well be that if this makes things horribly complicated, if it is very difficult to comply to this without shipping the full sources, then de facto LGPL 3 and GPL 3 are almost equivalent, at least insofar as the disclosure of the full sources is concerned. Okay, and then my last slide to introduce the talk of my colleague Dane. Conveying, I remind you, is things that you would need copyright permission for. So we are not used at all to the notion that shipping something physical would need a copyright permission, but things are not so clear. So what I propose is that we have some questions and some debate now, and then my colleague could give his short talk on this question and have another iteration of...
Perfect. Okay. I'm going first because I've got the microphone. First of all, thank you very much again. So can you go back to the first open question?
Yes.
So I'd like to just make a couple of points. So the critical mass argument is made quite a bit, right? So you know, build it and they will come kind of thing. They will start using you to build other stuff. I would argue that the hardware industry is a long way from where the software industry was in the 80s, right, when this kind of kicked off. So an analogy might be a situation where, imagine now we had no open source software. So 30 years into sort of, you know, desktop computing, and all of a sudden someone says, let's do open source software, and let's put in a strongly reciprocal license like the GPL, and have the same argument. I mean, it's sort of the same thing, I would argue. And imagine instead of every 10 software engineers, there's one, because there are far fewer hardware engineers in the world. So this is where I kind of, no, I'm a bit of a pessimist, you could say. I don't buy that we're going to be able to get the critical mass, given the way the industry works and how many players there are and how many engineers there are that can work on this stuff. So that's what I would argue here, that, you know, you say half-hearted, they use the LGPL. I would argue that's realistic. So that on the second question, I would say they're equivalent. I don't see how even in an FPGA bitstream you can then rip out the LGPL part and put down another without having to rebuild the whole thing. It's the same in an ASIC. So it's a very interesting situation. I mean, the software, the LGPL2 made it clear that the idea was dynamic linking in operating systems, right, where this sort of applied. And in this language, in this version, they've removed the software operating system explicit language, which is nice, but it still doesn't, I think, practically apply to hardware. And so that I've written a weak copyleft license, which is source code level, source code based on the Mozilla public license. And I reckon that does a better job than the LGPL3 of sort of achieving weak copyleft. So I'll open the floor up now to discussion, but I thought I would, the whole reason I asked Javier to have this presentation and have this debate is because I think people don't talk about it enough, and it's a big sort of, it is a massive open question for the discipline. And that's my opinion. I respectfully disagree with a lot of what CERN says. Well,
I have no opinion about this.
Yeah, so, but the lawyers do, and the lawyers will, say. So, let's start the conversation. I think Wesley had his hand up first. So.
Hey, so I chose the GPL3. And one of the reasons I did it was because of the patent clauses, because I want to force people to make their patents open, and the GPL3 will do that. Any company who uses my stuff is forced to let me use those patents.
Yes.
I didn't say anything about patents.
Yeah, sorry, that's an important point of GPL3, of course. And that goes also in the direction of less adoption, because many people who hold patents don't want to see GPL3 code in their stuff. But it is true that if your goal is to make sure that none of the products, including your stuff, has any patents that would preclude a user from using it freely, GPL3 is a very efficient method for ensuring that. Yes.
So one question was, in one of the slides you had earlier, the language, there was a language about, slides, running code.
Yeah, it's to run object code or to modify the work.
Is there a definition of run the object code in the GPL v3 that makes sense for hardware?
No, because it says here for an executable work, and I don't think a bitstream is an executable work.
Okay.
So I think it's really, they thought it through, because they had, I think it was the OpenSpark people that worked with the Free Software Foundation at the time. So they really had in mind that this should be applicable to chips.
Just a quick comment to what Julian said. People said the same thing 15 years ago in open source, with open source software. So it's a bit of, and one of the interesting outcomes was the most popular the biggest project, the project with the most adoption, and the biggest communities with ended up being the GPL ones, not the LGPL ones.
Sure. So but just to quickly respond to that.
I can give you a load of other reasons why hardware is not the same as software, which is why it's practically not going to, I think, work, and that's why you need to be a bit more optimistic. But anyway.
Hey, can you go back to the flow diagram?
Yes.
And also you're wrong.
Which one?
The ASIC one, I guess.
Okay.
Right.
I don't understand exactly.
Right. So you said GPL versus LGPL is left of logic synthesis, right? But
Red and blue.
red and blue, right?
Yes.
But the silicon cell library is going to the synthesis.
Yes.
So yeah. So if that's red, right?
Yes.
Which it's
But
right now
that's
it's all
system
red,
library.
right?
It falls under the system library concept. So these can be considered system libraries. As
Yeah,
per the
sure. But then
GPL definition.
if someone wants to do GPL, right? That means that the logic cells also need to be.
No, they don't, because they are system libraries, and the GPL license says that you don't need to ship or publish the system libraries. You rely on people actually having them locally, and that's the whole idea of the system library concept in GPL is that people have stuff locally available to them as part of their proprietary tools, and you don't need to ship that stuff, both proprietary and free, in fact. So if you can make this be part of the system library set, as per the definition of the system library, and I'm going to put it up here. So, system libraries. Here, a major component could be your IC design tool, okay? So, major component is defined here. Major essential component of the operating system, or a compiler used to produce the work, or an object code interpreter used to run it. So, if the tools that you use to design can be a major component, and the system libraries are packaged with those tools, then they fall under the definition of system libraries, and you don't need to ship them. Okay, so I haven't put the text of the GPL here, which says that you're not required to ship the system libraries. But trust me, it exists, and therefore if you think that these cell libraries are system libraries, then there's no problem at all with using GPL.
But I think what Janssen was saying is that if we go back to it, that red thing.
Yeah, that in logic synthesis you still have silicon cell library. So on the
Yeah, but again, they are system libraries.
I know, but that was the point.
My diagram is probably not reflecting reality, but basically what I say is that anything which you feed locally when you receive the GPL sources can be considered a system library, and therefore you don't need to publish it on the GPL. You don't agree?
Is it not more appropriate to say it's more like, in terms of software analogy, compiling, and you've got algorithms in the compiler which, for stuff like the views design compiler, you will infer adders and things like that. Perhaps that's I would argue, a more analogous description of what happens in synthesis. And cell libraries is maybe like the assembler, which takes some representation and maps it to like atomic things which are appropriate for the domain.
From a copyright perspective, which is what counts legally, right? You have files, right, which are under GPL, or you have files which are all rights reserved, and these files, these cell libraries, typically will be all rights reserved. Okay, if they can be considered by the definition of the system library to be a system library, and this is a big if, of course, then there's no problem with designing GPL sources.
I've got to stay, but I'll just focus on one minor technical point. In this Asic Flow, you cannot actually build a chip at the end automatically. So when you go do layout, the tools have bugs in, they always do. And the best you can do is get down to enough things that you can manually fix at the end to actually make the chip pass DRC.
Yes.
So there's a manual info right at the end, which I don't understand how you can satisfy the GPL if we have to ship YUN stuff to anybody who gets the code.
It's here. It's here.
It's done manually.
Yeah, it's done manually, but I mean manually without a computer. So it's
No, it's not rubylith. I mean, they're sitting in the computer and they're changing the
layout.
but you cannot send the layout
Yeah.
because the layout encodes a proprietary standard cell, so you're not allowed to ship the GDS.
Mhm. So you think these CAD files cannot be shipped?
No, they cannot be shipped.
Okay, good. Good to know.
But, right, so the other thing is GPL. I don't know if GPL says anything about patents in the systems libraries.
Good question. Anything about patents in the system libraries? I don't think they say anything. No, I think what it says is that when you release sources, all the sources that you release as a licensor, and then that the licensee is going to re-release again, all those should be free to use for anybody. So you release your control over the whatever patent would preclude or keep a licensee from using the stuff that you shipped as GPL. I don't think it's patents in the system libraries would be any problem, but maybe I'm wrong. Yeah, it sounds true, right? Okay.
I would like to focus more on the intent of the licenses, because I remember I reached out a few years ago to you at CERN and a few other institutes who were doing LGPL based HDL code to see why they were using it, and everyone seemed to have the same reason for doing it. They wanted people to be able to modify, to use the cores together with proprietary cores, but they wanted changes to the cores to be fed back upstream. So I'm not sure, I haven't thought about the wording here, but I just wanted to people to think about the intent.
Yeah, I think I also wanted to say that Julius's license does a very good job of getting rid of this problem here. So yes, this is a real problem, as we have just discovered. So that effectively means that LGPL3 is almost equivalent to GPL3, and GPL3 might itself be not exactly what you want, for some of us. So yeah, maybe worth having a serious look at Julius's text. Yeah.
So on the major components, it says to say it's a normal part of the tooling, right? So
there's many possible cases. It's not only that. So I agree that it's a stretch. Let's see.
Because you can buy in extra cell libraries, and is that their normal part? If you've got a special license, yeah.
So this would not apply. A major essential component of the specific operating system. It would be more executable work that runs or compiles.
I've got you. So this is clause B. Okay.
Yeah, it would be the second case more, but it is a stretch. Still a stretch. I agree.
Thank you.
Yeah, there is also a slight difference between FPGA and ASIC with the things that you produce. For example, the FPGA vendors actually make money out of the FPGAs they sell. So they are actually quite happy that the bitstream is available, and you know, as far as I know, all FPGA vendors allow the bitstream to be distributed. Whereas in ASIC, that's not the case. There are a lot of people who make money out of the Asic Flow in different ways. You cannot disclose the final CAD documents because it will contain some IP. It may be the IP, for example, technical rules of how that specific technology works. It will be, well, you can't disguise that. I mean, you will see all the design rules and everything, and that is an NDA that we sign on. So we can never release, I mean, even if I just blank away the silicon cell libraries, just the fact that I have a layout that passes a DRC allows me to reverse engineer it directly. So there's no point in signing an NDA on the process design kit, as they say. There are also other things. For example, the companies like Synopsys, Cadence, they make money out of converting it from one form to the other one. So the netlist can never be released in an Asic Flow because it would allow people to bypass buying licenses for Synopsys, and Synopsys will not be happy if I use his tool using educational license to create a netlist which I then make freely available. So nobody will, I mean, you know, in an ideal world, if I make the perfect result, nobody, and so that's the problem. I can't do that. Whereas in FPGA, it's different. The FPGA vendor wants to sell the FPGAs. They make money out of those. Not the tools, not the flow. The tool and the flow is sort of kind of a means of selling the FPGAs, not so in the Asic Flow. So it's a very different
Okay,
thing.
but if I understood well, among the things you have mentioned, many of them are things that the technology files that users of these would have in their local installations. So that's already not a problem. What I see as a problem is what Kirsty just mentioned, these CAD files that you cannot ship because of course they are needed to reproduce the work. Let's see, sorry, CAD files here. So the source code that you need to actually distribute is whatever allows a user to receive it, mix it with the local system libraries, and produce something useful, right?
I think one thing you're getting confused about, the standard cell libraries. These standard cell libraries are not standard. So you can go to company A to get them for process X, or company B to get them for process X.
What's the impact here? Because I mean,
they're not standard system things. You go and you choose them.
yes,
It's like I go buy a library for math functions from company A.
yes.
The library for math functions.
So your argument is that they cannot be considered system libraries?
Correct.
Okay. Again, go back to the definition and interpret for yourself if they can fit in there or not.
No, I think this would mean that those would be included as part of what you have to ship, which. And the other problem is...
No, they would be included as part of the tool. The major component is the tool you use. So they would be included as part of the tool that you use to...
They're bought from somebody else. They don't come along with the tool.
Yes, so I agree that the wording here is problematic. Yes. But it's a pity because I think what the FSF meant with this is that kind of thing. So that the wording doesn't reflect that.
Companies compete on the quality of their library.
Yeah.
That's okay. I mean, what's the problem?
No, it's just more IP.
Yeah, it's just more IP.
It's, the people who build those libraries consider them IP, right? Their IP.
Yes. So there's a scenario in which you ship your HDL, right? I get it. I buy the same product that you have bought locally, and I reproduce your work. There is nothing wrong with that.
So what's wrong with, okay, so then I can buy the core from somebody else and add that to the work and reproduce it that way.
Yeah, if it's a core, then yeah, we're
saying it's
talking
all
about,
different. It's just
we're talking about the difference between system libraries and
but then
covered work.
The point is system libraries don't come with the system. That you buy them separately, just like any other
Yes.
core or any piece of library.
Okay, so if you consider this part of the covered work, then it's a problem, of course. Yeah.
So just a quick question on that. More to the legal team, have you considered having an addendum to the GPL which clarifies those terms to mean that?
Okay, so you have a lot of time before the mic reaches you. Think.
I mean, we can circulate the microphone among the three of us, but so until now the answer is so maybe if I can reformulate the question. So if I understand your question is, did we make, if you want, a wrapper around the GPL3 which would clarify the definitions in the context of hardware basically design instead of making it tailored to software design? I think until now the answer is no, but in fact in preparation of this event and in fact the talk also that we prepared together with Javier and work that we intend to do in the coming months as well after this is exactly one of the things we are considering. How can you actually look at the question of, indeed, rather than trying to redefine a license, trying to redefine what the words mean in that license so that it is clear indeed to everyone how it applies to their specific scenario. And that's one of the options we are looking at as a next step. But today the answer is no. Also, Charlene and Miriam, if you want to add something to that? No, I see shaking of the head. But it's a good point. Yeah.
What I'm seeing here is that there's nothing in the Asic Flow that would make it impossible to draft a proper copyleft license, but it might be not this one.
Another question I have that's a little bit related is what you see, for example, in the FPGA flow, is that you can do a lot of generation using all kinds of wizards in generating cores that you insert inside your program. And yeah, it is some form of customized system library, you could say, but is it even possible to generate an entire FPGA or ASIC without using any restricted license, so to say?
Our experience, and I think we are quite representative of the community of people who work in physics labs and so on, is that we have lots of design which only use this, and we can distribute this so that people can generate these locally, and that's okay. So we have quite a lot of designs like that. They are not terribly complex, but they do the job, they do what we need. So it exists.
I think that was useful. Should we perhaps move on to the next talk? Yeah? Mm-hmm. Yeah. And discuss the final open question. Thanks again, Javier.